Hello everyone, in this video I'd like to introduce a script that I've written that allows to play with Katago, PlayOK.com, a fully automated script. And now script has just one, so this is the player CGN 811G. It just got out and it started a new game. So like it automatically ends the game, automatically starts a new game. The new game has started at 157 table. Let's search for that. And indeed, so here we got, so it started a new game. Let me bring it back. I spent 2 full working days to make it like bug free. Hopefully it's bug free. This runs for a few games already. I had some issues like it stopped working after a while, but after some fixes I think now it should be quite stable. So the idea is it's going to be playing in a never-ending mode. Essentially it responds instantly, but there is a 1 second delay, so that it's a little bit, it's not that annoying, so just 1 second delay is there. So how it's done? It's the interesting question, essentially. So earlier I had a version that did a similar thing, but there was no WebSocket connection from script to the PlayOK Go server. And instead what it did was the visual board recognition, essentially taking a screenshot, then finding where the stones are and translating that into the GTP move, and then translating the GTP response from the Katago engine back to the mouse coordinates and triggering the click event there. And that's the automation I've been using to play like in the previous iteration. But that thing could not automatically match the game, automatically finish the game, pass if needed, etc., etc. The only limitation is that this one does not select the dead stones, so it happens that opponent doesn't select the dead stones properly, and the AI would be having like killed like most of the groups, but they are not counted. In that case, yeah, I would lose. But most of the time, everyone just resigns, so it's not a big deal. And again, it's not just to get the best rating in the website, because it doesn't make sense. Engines are just much better than humans. Although this is the old network, 10 block network, 128 convolutional layers, like from 5 years ago or something. It's like very old. Very old, but for amateurs with a slow level, it's just good enough. So recently, I made a couple of programs. One was just quickly demonstrate. So the PlayOK Go Client, I have reverse engineered the PlayOK, so this website WebSocket, and I made my own PlayOK client to play as a human player there, because I don't quite like the interface. I think my interface is a little bit better. Also, it supports the auto matching stuff, which this one doesn't, and yeah, like straightforward solution to play games as quickly as possible. And another one is a very simple Katago UI that doesn't even have the front-end board representation, but entirely relies on passing the GTP output and synchronizes that with the graphical board state, which I find personally to be quite fascinating. So combining these two applications, sort of combining, but without any graphical interface, just hold a sec. Yeah, I'm sorry, just need to let my cat out. So combining these two, but without a particular user interface, just the bash script, we got this program that does the stuff. Okay. Player 1 resigned, so 157. but the timer was talking. Okay, so he started a new game against KGC. I'm not sure if this is the same opponent or a different one, but anyway, Seneca just plays in a never-ending mode, and again, I spent so much time to make it possible because, yeah, I couldn't, what I couldn't reverse engineer within the WebSocket messages is like the state when the game actually starts and when the game stops. But then I found a message where there is a single parameter that is responsible for that, so essentially -1 if the game is not active, and 0 or 1 for colors respectively is when the game is active, and that's how I could. That's the main parameter that I used in order to make the script looking for a game. So essentially, what it does, let's walk through the source code. I think that makes a bit more sense. So creating a WebSocket connection, spawning a child process. So these are the Katago net and the Katago binary path. So this is the Node.js, JavaScript, all the standard modules, no external stuff. Like I think these all are the standard. I think. I hope. At the very least, I did not do npm init and npm install or something. So here we spawn the Katago process right out of start. After that, after 5 seconds, to make sure that the Katago process runs and it's stable. Then we connect to the WebSocket. So connect to the PlayOK web server, PlayOK WebSocket to Go server to become online, to be online, let's say. So a few variables responsible for the game state. Function to accept the challenge, it sends the messages to the socket. The message essentially sends the message to the socket, encoding the user action into the WebSocket kind of commands that I've reverse engineered. So join to join the table, color to pick up the white or black side respectively, depending on which one is free, and then start, attempt to start a game. So there is a start button in the PlayOK interface. My PlayOK Go Client does not have that. I use the user prompt confirm prompt. Confirm dialog to say if I do yes, it's like sending the start. If I do no, cancel. It just doesn't send the start message. But here, it all happens automatically. So this is the command to join the table, command to leave the table, play white, play black. So take white stones, black stones respectively, and this command to attempt to start a game at a given table. And then after a timeout of 5 seconds, if it happens that the game is not active, it means that opponent refused to start a game or whatever reason, and we just leave. And then we'll find another one. And if the game is active, in case if Katago is playing black, it wants to clear the board to generate the move, the first ever move in the game. Show board is only used for debugging purposes. If you like here, show board is not used, but it can be turned on for debugging purposes. Down below, I'll show you that if I don't forget. So connect. So these are the credentials for the hard-coded credentials for the guest CGN811G. You may find these credentials in the browser in the Network tab while connecting to the WebSocket. That's essentially the very first message to connect to the WebSocket. So like initialize. If you add value of the K session, so-called, before this one, and these values might be essentially whatever, just add the K session. If you get that from the login, like you need to make a HTTP post request to the endpoint, to the login endpoint. If you're interested in how to do that, you may check out my PlayOK Go Client. It's implemented there, it's quite easy. But here I didn't want to do this, just if someone who's not very good at programming maybe, but just wants to cheat, takes the script and wants to connect this to his very own account. To prevent that, I didn't provide this kind of functionality. But for those programmers who are just interested like how to implement the login, that's fairly simple. And again, my PlayOK Go client essentially has that, so you may have a look at that there. It's all fairly similar. Okay, So finally, we are connected to the PlayOK socket, and every 5 seconds we are sending the keep alive message, which tells the server that we are online. Then we are decoding the messages, that different types of messages that are coming from the WebSocket to the client. So login pairing code 70. So essentially, what we want to do, we want to, if black is taken and white is free, we want to play as white. So I say accept challenge as white, and the player one is just probably to tell whom I'm playing against. So it's not probably even used anymore. The player is probably not even being used anymore. Yeah, it's not used anymore. Yeah, I was using it for a message, but essentially I can leave this. Yeah, probably may put this into the to-do list. Yeah, just put a quick note. Yeah, because I just forgot about this. Forget about this if otherwise not put this down on paper. Then this one is responsible for loading the game, so it's like all table centric. So once you're in a table, there might be a game already. There might be a game that is restored from the broken connection. It's not used in this particular case, but just generally how it works. So the game is loaded, whatever position, if the pool full of stones, or a new game, like if the new game fires, it's also like this command, like code 91. And then just we want to play all the moves available. It's always needed, but yeah, just made it for debugging purposes. Essentially, this probably is not much needed unless you want to continue the game that after disconnection or something. Probably in that case, that would have been just maybe. But again, with this script, with the context of this script, since the table variable, and it's probably another useless thing. I don't even know. I don't even know. Okay, just leave it for legacy. Yeah, like it's not needed. I think this is not needed. I'm not quite sure, but again, this is like for the purity of the how the server works itself. I don't think this is really used, really like needed much for this script to run properly. Update the move is the core thing, so that might be either pass or the move, and it sends the play command to the GTP process to Katago essentially. Then you change the side, and the side is equal to the Katago side. We're generating the move for a given color. That's it. Chat messages. So this line simply prints all the chat messages into the console. And in case all these scenarios are like either the game is over due to resignation, like scoring, exceeded time, or maybe you have been booted by the table operator, or opponent is offline, or you have been displaced. In this case, we just want to leave because the game is over. We want to start a new game anyway. This is the core thing, really. So these two lines initialize this active game, which makes huge sense because when we know the game is active, we want to play the first move with AI if this is black turn. And also when we leave, okay, when we start. Yeah, if the game is not active, then after we send the start and say opponent didn't press the start, didn't click the start. In that case, we know that we want to leave from the table. Otherwise, AI would stuck on a single table, and even if the game starts again, it would not be capable of making moves back. So that's the thing, essentially. What else? What else is almost over? And in case if it ever gets to the counting stage, it just sends pass all the time. Even if there are dead stones, it's not going to be selecting the dead stone. Just sends pass, so there is a chance to win. If AI does not select the dead stones, and you either, then you can win. So that's the hidden chance. For those honestly playing to the very end, yeah, that's the hidden chance. All right. So events, the error of the socket, the close. On close, we just kill everything, yeah. And these are the handlers for the Katago output. So we interpret this output. So if uncommand this, it just prints all the messages from Katago. But we don't quite need that. So what we need is the move, which is extracted using this regular expression. Then what? We extract the move, we convert move to the square index, and we send this square index. Yeah, here I could just do the square, I guess. Or I can remove this one. Whatever you like. Whatever you like. Can be done like just square. And sending these to the socket after 1 second. So the bigger this value is, the longer it takes to respond to a move. Obviously, making like 1,000 playouts, say, would make my poor Raspberry Pi 5 working for a long time to output the move. So that would naturally increase the timing of the response time. Also, in category settings, you may set up the time control, like probably it supports at least 1 second per move. Think 1 second, think 2 seconds, etc., etc. So handling pause, handling resignation. If so, I've been using this for debugging as well. So when the board is up, when we output board, when Katago outputs the board, this is used. And in case something goes wrong, the legal move, I've been here for like thousands of times during debugging, yeah, it was also quite helpful. Essentially, this is it. It also sig interrupts, so on Linux, this is like Control-C, it forces the resignation. And the script then tries to find another game, new game, and goes from there. Okay, let's see if it still works, and damn it, it still works. This is so cool. I was struggling for such a long time, to be honest, with this. Yeah, it's already started a new game, so let me quickly see the game table. 112. So 112. This one. So yeah, plays as white. It plays both colors, not only white, it also plays black. You may play black or white, doesn't matter. So it keeps playing. And yeah, so I'll probably leave it running the whole night long and see if it would be stable enough or not. And that's it from my side, guys. Thanks for watching. Hope you've enjoyed the video. Yeah, maybe see you, maybe not. I don't know. Cheers.